A terrestrial mass exoplanet was discovered, orbiting the red dwarf Gliese 1151. According to astronomers, magnetic interactions between the newly discovered planet, which has been designated as Gliese 1151b, and its host star are the likely source of low-frequency radio emission that was recently detected from within this system. According to researchers, planets in close-in orbits are embedded in a magnetized stellar wind from the expanding stellar corona. As they orbit, short-period planets can perturb the flow of the magnetized wind, which can carry substantial amounts of energy towards the host star via subalveolic interactions. This incoming energy can heat up the chromosphere of the star, causing a hot spot on the surface of the star, which can cause variability that is modulated by the orbital period of the planet. In 2019, a team of astronomers from Europe and the United States discovered highly circularly polarized radio emission at 150 MHz in the direction of Gliese 1151, a quiescent M4.5 dwarf star, which is located approximately 26 light-years away in the constellation of Ursa Major. They were using the LOFAR telescope array. The emission properties were consistent with the theoretical expectations for star-planet interaction with a rocky planet in an approximately 1 to 5 day long orbit. According to the researchers, their aim was to detect the candidate planet using a radial velocity method. They further went on to analyze the data collected by the Habitable Zone Planet Finder spectrometer on the 10M Hubble Eberly telescope at McDonnell Observatory, the HARPS N spectrograph at the Telescopio Nazionale Galileo, and NASA's Transiting Exoplanet Survey satellite. The observation revealed a periodic Doppler signature consistent with an exoplanet on a 2.02-day orbit. This detection encourages further synergies of precision radial velocity and low-frequency radio observations with facilities such as LOFAR and the Square Kilometer Array in the future to detect and characterize planets around nearby stars that are exhibiting coherent radio emission. From radial velocities obtained with HPF and HARPS-N, they constrain the planet's minimum mass to be 2.5 of Earth's masses. The United Arab Emirates' first interplanetary mission, called HOPE, and the first of 3 spacecrafts launched to the Red Planet in 2020, will attempt to enter Mars orbit. In July, a trio of Mars-bound missions left Earth, and currently the first spacecraft is about to reach its destination. HOPE spacecraft's arrival at the Red Planet will truly start the United Arab Emirates' first interplanetary mission. It has been called HOPE, and it coincides with the 50th anniversary of the country's independence. The UAE's space agency will broadcast the event starting at 9 a.m. on their websites. Of course, it is also encouraged for persons across the globe to watch the stream of the HOPE spacecraft arriving at the Red Planet. The HOPE probe is an orbiter that not only represents the UAE's first foray into the solar system, but also a new era of cutting-edge Mars science. HOPE will diligently observe the Martian atmosphere, helping scientists to better understand interactions between its upper and lower portions. The orbiter will also track characteristics such as temperature, humidity, and dust levels for an entire Martian year, which is equated to 687 Earth days, or a little less than 2 Earth years. Regularly painting a global picture of atmospheric conditions every 2 weeks, This comprehensive approach will allow researchers to track how molecules escape Mars's atmosphere into space, a process which, over billions of years, has transformed Mars from a wet, warm environment into a cold, dry, and dusty planet. The UAE has announced that it will freely share the HOPE mission data with hundreds of institutions across the globe, cementing their place as part of the larger science community. HOPE launched from Japan's Takagashima Island aboard a Mitsubishi MH-WIA rocket on July 19, 2020. The successful liftoff marked the end of a 6-year effort by the UAE to develop, construct, and launch its first homegrown interplanetary mission. To accomplish such a lofty and complex goal, the group sought collaborations with other research institutions to bring interplanetary experience to the fore, which included the University of Colorado Boulder, Arizona State University, Northern Arizona University, and the University of California, Berkeley. Concluding its 7-month, 307 million mile journey, which is equated to 493.5 million kilometers, the orbiter will begin its Mars orbit insertion phase on February 9th. HOPE will first set off its thrusters to slow down, allowing Mars's gravity to capture the 2,970-pound craft in orbit. According to the space agency, the slowdown will burn almost half of HOPE's available fuel supply to reduce its speed from more than 75,000 miles per hour to 11,000 miles per hour over the span of just 30 minutes. If the maneuver is successful, HOPE will end up in an elliptical orbit with a period of 40 hours, swinging as close as 620 miles and as far as 30,700 miles from Mars's surface. The team will then start a second test of HOPE systems and instruments. The first test occurred after the spacecraft's launch, before the science mission began. Engineers will do further work on HOPE's orbit into its final optimal science orbit, which is an elliptical orbit lasting 55 hours. That takes the probe between 12,400 and 26,700 miles off the surface. Like, comment, share, and subscribe. Thanks for watching. Goodbye.